Picture two identical human brains. One of them belongs to someone who is half asleep, their mind drifting with no particular focus. The other belongs to a composer, silently writing a brilliant, unrecorded symphony entirely in their head. If you put these two brains on a scale, they would be physically indistinguishable. They both weigh roughly 1.4 kilograms. They both contain exactly 86 billion neurons. That unwritten symphony is not an abstract concept. It has a physical trace. Every note exists as a specific molecular configuration of synaptic weights. Now, let's run a thought experiment. Imagine we take both of these brains and we drop them into a black hole. According to the Bekenstein-Hawking entropy principle, when an object falls past the event horizon, the black hole gets larger. Its surface area increases based strictly on the mass and the total number of physical microstates it just swallowed. Here is the paradox. Because both brains possess roughly the same mass and number of particles, the black hole registers the exact same entropy increase for both. It completely ignores the masterpiece. Fundamental physics perfectly registers the raw data of a thought, the mass, the energy, the atomic structure, but it has a semantic gap. It is entirely blind to the meaning. We see this exact tension today, not in deep space, but in neuroscience. You have probably seen headlines claiming that artificial intelligence and brain scans can now successfully read human minds or reconstruct images directly from our thoughts. This diagram breaks thought detection down into a four-tiered pyramid: existence, detectability, decodability, and fidelity. Science has firmly conquered the bottom two tiers. We know thoughts physically exist, and using sensors, we can reliably detect the electrical or metabolic signals those thoughts generate. Current AI systems operate at level 3, decodability. They don't pull exact pictures from your head. Instead, they classify your brain activity into broad buckets, recognizing that the signal looks a lot like the concept of a dog. Then, generative models take that weak semantic hint and hallucinate the rest. They fill in all the high-resolution details using their own massive libraries of training data. This leaves a massive barrier before the final tier: fidelity. We still lack any scientific method to extract the specific, novel thought you are actively experiencing. Those visually impressive mind-reading demonstrations are an illusion. They combine basic category classification with AI generation to make it look like they pulled a photograph out of your brain. If a thought is a physical arrangement of synapses, why is perfectly extracting it impossible? Physics sets a floor on how efficiently information can be processed. Landauer's principle shows that every single cognitive act has a minimum thermodynamic cost, which dissipates energy as heat. As your brain works, the physical information of your thoughts leaks into the surrounding environment. It gets redundantly copied into thermal photons and molecular vibrations moving through your skull. But an information theory rule called the data processing inequality guarantees that every step of this environmental thermalization irreversibly degrades the original signal. To actually read that specific thought from the outside, you would have to calculate the precise reverse trajectory of trillions of scattered particles simultaneously. The raw physical data of your thought does survive in the environment, but its structural meaning is thermodynamically destroyed the moment the heat leaves your head. Internally, the human brain holds a staggering amount of data. By measuring the structural limits of our synapses, scientists estimate we can store roughly a petabit of physical information. Yet our external output, the speed at which we can consciously type, speak, or report our choices, maxes out at roughly 10 bits per second. There is a massive bottleneck between what we experience and what we can share. This mismatch mirrors a strict limit in how we study the universe. Scientific laws measure the maximum data capacity of a physical space. They don't evaluate what that data actually represents. To physics, a hard drive containing a literary masterpiece and a hard drive filled with complete random noise are identical. If the file sizes match, they hold the exact same amount of information. Physics has no mathematical equation for human meaning. This is not a flaw in the equations, it is a boundary line of what science can measure. Which brings us back to the black hole. The laws of quantum mechanics, specifically a principle called Unitarity, guarantee that the physical bits of your unspoken thoughts are never truly destroyed. They will survive forever, scattered across the cosmos. The raw physical data of your mind is public to the universe, but the meaning of those thoughts belongs exclusively to you.